Oh, welcome everyone. We're at the end of this chapter working on negative numbers, and to me this is probably the most interesting bit or part of the journey. What we've been looking at is looking at the number line, in really one-dimensional type situation here, reading the positive side and the negative side of the number line. And even if we do something like this, make sure I get this the right way around, I often think about a thermometer as just a number line that's been turned in the vertical direction, up and down. Okay, so there's a big leap coming to us now that we're going to have both the horizontal negative number line and the vertical number line plotted with each other. So now we've got something here. I'm just going to quickly roughly sketch it here. We've got this type of situation here where we've got two sets of axes. Okay, we've got a horizontal number line with a positive and a negative side to that. We've got a vertical number line, and that has a positive side and a negative side to it. All right, so these were massive big ideas back. I think Descartes was one of them, and that's why we called it the Cartesian plane. I think there's another guy at similar time come up with a similar sort of idea. And what I've got here, what I find interesting here is we sort of one of the big problems that needed solving at some point, and it's not really what we think. We take it for granted these days, don't we? We get our phone, we get a GPS, we can plot a point and plot another point and map the distance between them. We can put in a set of coordinates on our GPS and follow the arrow until we get to that waypoint. It's pretty easy. But back in go back 400 years, 500 years ago, they were real issues that needed solving. This is kind of like my three-dimensional model of the world, right? I've just used some origami to make my planet Earth here, and for our modern GPS system to work, we've got to have a point somewhere, and maybe this is on the equator, and we can think about, for historical reasons, maybe this is Greenwich up here, and down here on the equator here we've got somewhere on the west coast, off the west coast of Africa on the equator, we've got a place. Well, it's not a physical island, it's called Null Island. It's a buoy floating in the ocean, and I think it's tethered to 5 kilometers of chain to keep it in place at the bottom of the ocean on some anchors there. But we need a place on this planet that we're going to call 0 degrees latitude, 0 degrees longitude for the rest of our coordinate system to work. And it's called Null Island because its coordinates are 0, 0. And in two-dimensional space where those axes cross each other, we have what's called the origin, and its coordinates are 0, 0. And then we map out various points from the origin. And there's a few tips, and what I would say to you is that you've got to remember, always try and keep in the back of my mind, always read the x coordinate first. X, then the y. The x-axis is always going to be the horizontal axis, and the vertical axis will always be the y. But I'll map those things out for you and show you in a little bit more detail the specifics of what you need to remember on the number plane. All right. We're talking about the number plane or the Cartesian plane. I know those words are being used interchangeably in your textbook, and we're talking about a 2D world here. Plane means like a sheet of paper, a flat surface, two-dimensional shape, okay? And we can, like I discussed somewhere, in our coordinate system, we need to label something as the origin. So where those coordinates are here, we've got the origin here. And those coordinates are 0, 0. I'm going to remove that in a moment. What you tend to see is just a tiny little O under here. Okay? You barely see it and you barely notice it. Okay? So what's important is that we give our coordinates the x coordinate first and then our y coordinate. So x comma y is often something that's always running through my head. And what we need to do really carefully is label our axes x and y. That is super important. And like I said, the x-axis is always the horizontal axis. Okay? So what we need to think about here, if we just think about what's happening on this axis, they're positive numbers. And over here, we've got negative numbers over on this axis over on the negative x-axis. And the vertical axis here, these numbers going up are positive and these numbers going down here are negative. So what we end up in a situation, if we just put x comma y out here, we have positive values of x, positive values of y. If we shift over here, x comma y, we have negative values of x but positive values of y, and we can go around each of these four quadrants that we call them. I'll point that out to you in a moment. These are negative and y is also negative there, and over here, if we think about what's happening with these sets of coordinates, we've got positive x coordinates and negative y coordinates. So I mentioned a word there. I said quadrants, and what that means is that if we cut up that sheet of paper into 4 equal bits, if we put the origin right in the center of the bit of paper and then got the scissors and cut it out, we would end up with 4 quarters. And what we tend to do is label that as Q1, Q2, Q3, Q4, just short for quadrant or quarter. Okay, so what you'll often be asked to do in the early stages of these questions is to you're given a point up here, might have a letter on it, might be the letter A, and what you need to do is read off the x-axis first. And what I suggest you do is somewhere on your page you write nice and big x comma y. So for example, if that was 2 and that was 3, would read off the x-axis first and write down 2 comma and then look across to the y-axis and write 3. Now you're most welcome to make that positive and positive 2 and so on. And just be aware, the big trap is when you move over here and this is -2, you don't necessarily put the minus sign down here. For example, let's call this point B. So A is equal to that, and point B is minus 2 on the x-axis, and I'm just going to make something up here, minus 4 on the y-axis. So hopefully you can see that it's really important to get that right, and the only way to get it right is always be thinking about the x-coordinate first and reading off the x-coordinate off the axis first and getting that right, and then the rest of it just falls into place. I'm just going to clean the board, and there's something else I want to show you. Nice simple sort of tip to help you sketch these coordinates on the Cartesian plane or the number plane. Now, some questions here you're given a table x and y, and I always like it when there's somewhere in here there's a 0 value. When x is 0, y might be another value. So let's make that 1. Okay, and let's fill in a few other x, minus 2, minus 1, and positive 1, positive 2. What I suggest that you do is see how I've located the y-axis where x is 0. So that's that point there. And we'll fill in a few other points here, and we'll begin sketching a graph. Minus 1, 0, if that's 1, that's 2, that's 3. Okay, so now we've got our table and our graph all lined up together. And what we can do is read off these points. And my tip here is just, let's make this minus 2 there, minus 1. Let's make that 1 there and 2 there. See how they kind of line up with the values in the table? We've got all our x-coordinates in here now. So this part is done. And now we've got to read off the values here. And we've just got to be careful, right? So minus 1 on the y-axis is down here somewhere. So at minus 2, we come down here and we either put a dot or a cross. And then at minus 1, the value of y is 0, so that point is there. And at 0 on the x-axis, this point here, we're told that the value of y is 1, so we put a cross there. And at 1, we're told the value is 2, so let's put a mark there and put another mark there. And then at 2, we're told that the value is 3. So hopefully you can see how I've been building up my sketch on the number plane. And it's been really systematic about how I've gone about it. The final icing on the cake, if you like, is to write the coordinates down next to each point, remembering that it's always x comma y. So this one would be minus 2, minus 1. This point, next point would be minus 1 on the x-axis, 0 on the y-axis. This point here would be 0 on the x-axis, 1 on the y-axis, and here we've got 1 comma 2, and we've got 2 comma 3. And that would be a really nice way to set out your graph. And I know it's drawn by hand, so it's not millimeter perfect, but it's a pretty neat sketch, taking the information out of the table into the graph below. So they're the kinds of things that I would encourage you to do. All right? Thank you.